Alright, we're going to look here at an example problem about a block sitting on an incline. Okay, and we're going to talk about the tricks that we can use to help us to be able to solve and be able to understand the different forces that are acting on this block here. Okay, first off, we recognize that the block is sitting still, which means that it is in equilibrium, which means all the forces on it are balanced in both the x direction and the y direction. Okay, I'm given that the ramp is at an angle of 11 degrees from the x-axis, that's right here, so 11 degrees, and then I know the mass of the block. So the first thing I'm going to do is let's draw a force diagram as is right now. So here's my block, and then we've got the force of gravity, which is pulling down on the block. We've got the normal force, which is opposite to the direction of the surface, right? So the normal force of the ramp pushing up on the block, and then there's got to be something balancing out the fact that the normal is not straight up and down, and of course that is that the block wants to slide down the ramp. Since it wants to slide down, it's going to have friction that is opposing it in the opposite direction. So the friction has to be parallel to the ramp. Okay, so we've got our forces there. Now, we can solve for the force of gravity. The force of gravity is the weight of the object, and we talked about in class how we get the weight by taking negative 9.81, which is the acceleration due to gravity, and multiplying by the mass. Now remember that the mass has to be in kilograms, so that will be 0.270. And so the force of gravity is negative 2.65. Okay, negative 2.65 newtons. Okay, now I've got two unknowns, and the problem here is that these two unknowns are both at an angle, which makes it slightly difficult. And so what we want to do, so that we don't have to do trig on unknowns, and so that we don't have two unknowns, is that we will take this and we will tilt the axis. So instead of the x and y being straight up and down and left to right, we're going to tilt it the angle of our ramp, which we have there is 11 degrees. So I'm going to tilt it now so that it looks more like this. Okay, so I've taken what was straight up and down and I've tilted it 11 degrees in that direction. So this is now up for the y and down for the y. Then there's my positive x, my negative x going that way. Okay, you'll notice now that the normal force is straight up and down on my y-axis, and the frictional force is straight to the left. Okay, now if this is a little difficult for you to see, then you may want to take this and redraw it. Okay, so I'm going to redraw it, but I'm going to redraw it so that my tilted x and y are now straight up and down. So I'm going to take the whole picture here and now rotate everything to the left. Okay, so the normal force then was straight up and down. So that would be the normal force of the ramp, right? I can tell it was straight up and down on my y-axis. The force of friction has to be perpendicular to that in the negative direction here, right? And then the force of gravity isn't going to be down anymore because I've tilted everything 11 degrees. And so that means there's my positive x and my negative y, so that means the force of gravity will be down here somewhere. Okay? And now it should be fairly easy for you to write your equations, right? We've got the x component, right? And in the x direction we have the force of friction, and we've got the force of gravity in the x direction, and those have to balance to equal 0. Okay? And then in the y component, we now have that the normal force plus the force of gravity in the y direction should equal 0. Okay, so now all you need to do is find out what the force of gravity is in the x and y direction now that we've broken it up. Okay, and so we'll do that just by using trig, right? There's the y, there's the x, and we know that the angle is the angle of how far I've tilted my axis, which was 11 degrees. Okay, the force of gravity is still negative 2.65. Okay, and so I should be able to use trig now to solve for the x and y components. So the x component will be the sine of 11, so it'll be 2.65 sine 11, which is 0.506. So 0.506 newtons. And then the y, of course, will be 2.65 cosine of 11, which is 2.60. So 2.601. And that will be my y component. And so now I can put those in. The y component obviously here is going down, so that'll be negative. The x component is positive, which means it's going, because it's going to the right. And so now I can plug these in, right? The force of friction, I still don't know what it is officially, but I do know that it has to balance out this 0.506, which is the force of gravity in the x direction, right? So I subtract 506 to each side, and the force of friction equals negative 0.506. And it makes sense that it's negative because it's going in the left direction, right? And then the normal force, right, plus the force of gravity in the y direction, which was negative 2.601, right? So I add 2.601 to both sides, so the normal force is 2.601. Okay, so that is the magnitudes of the frictional force and the normal force. If I were then to have to say the angles, then again I would have to go back and find out exactly what angles these are at with the normal force and the frictional force. The nice thing is that this tilting will always work because the normal force is always perpendicular to the surface, and friction has to oppose the motion. And so since the motion is going to go in the direction of the surface, since it's going to slide along the surface, then those two will always be perpendicular. And so most of the time this tilting will work, and we'll be able to use it to simplify our problem. So I hope that that made sense. If not, go ahead and look at the next video, and we'll do a similar type problem that's slightly more complex. Good luck.